Hi, my name is Štěpán Davidovič and I am currently a senior staff SRE at Google, and I'm here to talk to you about alerting and alerting toil and patterns and anti-patterns of how to handle and respond to alerting setups in your organization. But before we talk about any of that, first we should talk about what is an alert. And really, when we're thinking of alerts here, at least in this presentation, we're thinking of something that maybe wakes you up at 4 a.m. and goes, hey, your system is broken, it's on fire, you need to do something about it right now. But it doesn't have to be just that, it can be something less urgent. Maybe it is a ticket telling you, hey, in about a week, you're going to run out of disk space. It is still important and there's still consequences to not doing it, but it's less time sensitive. Now, in either case, it is something that interrupts your workflow to some degree. It is some additional extra work, and there are consequences if you don't do it. It is a source of excitement, but probably not something that you actually want. It's not a desirable excitement. But most of all, it is work that you as a human need to do. The system is not able to take a remedial action on its own, and it requires your human creative brain to actually do something about the situation you're in. But more specifically than that, we're going to be talking about automatic alerting. So while your boss walking up to your desk might be very important, it is not going to be in scope here. And the reason is that, you don't really get to control that, and at least certainly not as much as you get to control your own alerting configuration in your alerting system. And so when we're talking about automatic alerting, it's important to remember that by and large this is a forecasting problem. And one way to look at it is, an alert that tells you that your house has just burned down, it's accurate, it is free of any forecasting questions, but it's also not very useful. A much better alert would be something that tells you, hey, there's a lot of smoke, maybe you should go and check it out. And similar problem applies to our own alerting, right? We have an interesting trade-off. With more data, we might be able to more accurately tell you whether something is going wrong or maybe whether it's just some benign blip. But if something is actually going wrong, then waiting for more data and more evidence actually prolongs the outage. And so the outcome is that you do not really have a guaranteed correct alert. It is a trade-off and you're making this as a decision. Okay, so now that we have talked about what is an alert, what is a good alert? How do you really know? And what are the properties? It didn't seem like there's actually a clear objective measure of what a good alert is. And in part because it can depend on the beholder. You might have two operators actually mutually disagree about whether an alert was good or bad, whether it actually was useful. And a bunch of situations can be constructed to illustrate that. For example, if you have two consecutive alerts that, one comes after the other, was the second alert good or bad? Maybe. Does it advance the knowledge that you have? If so, probably yes. If not, then it was just redundant. But it was still the same alert, it just depended on where the operator is in their understanding of the outage. Still, there are some good and useful proxies. For example, timeliness. Did the alert actually arrive as fast as possible? And again, we've talked about this a little bit. There is a trade-off, but if it comes really, really late, it's clearly not going to be useful. The next one is correct delivery. And while that may seem at face value obvious, in a distributed system, it is not always clear which recipient is the best recipient to respond to a given alert and resolve a situation. Next one is information. Did the alert actually tell you anything? Imagine an alert that would be really accurately monitoring your system, but all it would tell you is something is wrong. Now, that alert might come at the right time to the right recipient, and yet is still quite useless. And the last one, and perhaps most important, but also definitely most objective, is actionability. Is there something that a human operator can actually do or should do as a result of this alert? And maybe the answer is, in fact, maybe. Sometimes the action isn't clear, sometimes that only becomes clear later, and sometimes you might go, yeah, I should do something about this now, but maybe in the future this should be automated. So it is again contextual. Of course, this list is not necessarily exhaustive of all the potential properties and proxies we might think of when we think of good alerts. You might have your own, specific to your business, specific to your organization, and to perhaps how you can organize your incident response. And as well, in some cases, you may be willing to compromise more. If your system just fundamentally doesn't require fast response, then timeliness is perhaps less of a priority than being informative. And so it's not only that these might be some of the properties and not all of them, but as well, you might be giving them different values and different weights than some other company or some other organization might. Okay, so we've talked about alerts, but your experience as a service owner and service operator is not just based on any single individual alerts, it is based on the entire collection, the entire suite of alerts that you have. And so let's look at how we can maybe reason about them a little bit and give it some structure so that we can also find potential patterns and anti-patterns in how alerts are set up. So we're going to look at alerts in three broad categories, and we're going to organize it in the form of a pyramid. The first class we're going to look at is reactive alerts. These tell you that something is currently actively broken right now. Something is broken and might get even more broken in the future, but still, right now, your business goals are currently being actively threatened. And usually these are the alerts that end up on your pager and that require most immediate response. A prominent group here are SLO alerts. They basically tell you that your service level objectives might be at risk if the current situation is ongoing for an extended period of time, and you as the service operator need to jump in and need to take some action to prevent that. Or rather, going back to the forecasting problem, the alert with the information available to it at the time of being issued believes that it's not going to just get better on its own. It is reasonably confident that you need to take action. With that in mind, that is not the only kind of alerts that are reactive. You do not actually need to go through the entire process of figuring out your business objectives and understanding the business trade-offs, setting up error budgets, or any of that reasoning, and still have some intuition about what it means for your service to be broken and your business goals to be at risk. And in the model that we're using here, they really form the base of the pyramid. The intuition is that if you can't tell that your system is broken for your users, if you can't react to problems in it that already manifested to your user base, that might mean that you're largely flying blind. And we're going to talk about the implications of that and how that manifests a little bit later on. The next class of alerts that we're going to look at is proactive alerts. And they happen when you have something bad going in on your system, but your service is just fine. There's no user impact. Nothing bad is happening. A good example are alerts that warn you that you're running out of disk space. Up until the exact point when you do run out of disk space, your service is operating just fine. There's nothing to react to. There's no SLO burn. There are no problems to deal with. But from the point when you do run out of disk space, let's say your service actually needs to write to disk to function, then from that point on, you are hard down. And so there's nothing to react to right now, but boy, is there a problem going your way. As you go about designing these alerts, it's important to remember and think about how much would it take to remediate this. Can you get more disk space in an hour, in a day, in a week? What would it take to actually get out of the problem, get out of the risky situation? And the third class, the tip of the pyramid as it were, are investigative alerts. They don't tell you that something will go wrong as when you run out of disk space, but I do tell you that something is going wrong in your system as a whole and that it might be worth investigating. An important distinction is that investigative alerts do not have any timeliness expectation associated with it. So unlike proactive alerts, which tell you, hey, if you run out of disk space, you're going to have a really bad time, here you don't have anything like this. You're just told, something is very strange in your system. You might want to check it out. they might be detecting things that might become really, really important, maybe critical parts of an outage, a very severe outage that your system would face. So if you have, for example, a slow memory leak that is a result of some bug in your code, and then due to maybe product change, that bug is triggered more often and you start losing all your replicas as a result of the memory leak, well, that is a dramatic event, and that couldn't be easily forecasted in any other way. There's no specific timeliness expectation to handling a memory leak, and yet this is the result. They rarely require actually immediate action. Other alerts are probably already detecting your situation if that's the case. But as they keep accumulating in your system, they might increase how brittle your system is and remove any ideas of resiliency from the systemic structure. So the question to you then is, do you want to know whether you have a memory leak and also sometimes a segmentation fault and also, because these can accumulate and become increasingly likely contributing factor to a potentially very impactful event. And so these three classes of alerts form the hierarchy that we're building here. They do not have the same urgency. Some of them require immediate action. Some of them are something to think about, but not maybe investigate right away, maybe not even this week, but something to be aware of in your system. As a consequence, they also don't have to go to the same people. It's probably very important that if you have an on-call team, that they are the ones who get paged when something is really broken in your system and you are maybe burning your error budget. But maybe that's not the right destination if you have a suspected memory leak. Maybe that is better sent to the developers of the component that appears to be leaking for investigation and maybe part of their regular bug triage and investigation process. In either case, it is an event where you have discovered something wrong in your system, and as a result, you have issued an automatic notification. And so we will use these three classes of alerts to talk about patterns and anti-patterns in alerting. So the first anti-pattern is when you have mostly or perhaps exclusively just investigative alerts. And this is something that you might have heard talked about a lot, like getting alerted for very high CPU usage. What does it actually matter how much CPU usage you have, for as long as you have enough capacity to serve the expected user demand? And there's a few ways you can use to tell that this is happening to you. One way is to look at your past incidents. If you look at the retrospectives that you wrote for things that were impacting your users, did you find that you didn't really get alerted for anything pertaining to SLOs? So it was always something like CPU usage that told you that users may perhaps be suffering, and then maybe you had a really hard time trying to connect the dots, like, is the CPU usage actually bad for users or not? Another potential telltale sign is that many or most alerts that you would consider investigative in the taxonomy that we just talked about are given paging priority. Someone would actually perhaps get woken up at night for very high CPU usage, even though it might not mean anything at all to the actual user base. In a sense, this means that the pyramid that we've got is heavily biased towards the top, towards the perhaps least important alerts to have, and you might be missing the foundations altogether. So if you do find yourself in this situation, what can you do about it? What are the next steps? Well, one of the first steps might be to look at defining your SLIs and SLOs for your system. Really think hard about what does it actually mean for the system to be broken. It might be that the CPU usage is very high for some specific systems, but it probably isn't. And so trying to understand how do you exactly measure user satisfaction with your service is the first step. By so doing, you stop any kind of speculation about the meaning of CPU usage, because you can point at the one canonical agreed metric that tells you this is good or this is bad. A thing to bear in mind is that alerting or things like SLO might actually be a little bit slower than if you alert on things like CPU usage in practice. It doesn't have to be, but it can be a frequent outcome, because often we find that the CPU usage or crashing or alerts like this are quite sensitive, and that might actually be counterproductive. Another really common anti-pattern, maybe connecting to the previous, is that the total set of alerts is just too much. Like, you don't have problem with any particular alert, you don't have significant bias towards the CPU usage or crashing alerts over the world, and yet you find yourself just drowning in alert response, responding to tickets, investigating, and trying to get ahead of it, and you just can't. For example, you just received too many paging alerts. Having one on-caller is just not enough. Maybe you need 2, you need 3, whatever it takes to respond to the paging load. Or it might be that those alerts are not actually paging, but you are still receiving a lot of tickets, things that are worth investigating, or some proactive warnings. And as a result, you have a really hard time triaging them and deciding what is important or not. And you end up dropping work on the floor, dropping important things on the floor, and you declare some form of ticket bankruptcy. You throw your hands in the air and go, yeah, I can't deal with this anymore. In short, the flow of inbound alerts is just greater than what you can process and handle with reasonable accuracy and thought. So if that is your situation, what can you do about it? Well, none of the alerts themselves are individually bad, and you don't feel like you have a particular bias towards something. All of these things seem important, and that's really a big trap. They seem important, but at the end of the day, you only have so many hours in a day, and you need to be able to prioritize strictly so that you don't miss out on the things that are important just because you are fighting a deluge of alerts. And so this is where thinking about alerting in the form of hierarchy can really help. In this case, you can climb down the pyramid and decrease the investigative alerts as much as you can. Again, this might depend on how you do the alert routing. Maybe those go to a different group, but still, in the grand scheme of things, if you have too many, see if you can reduce it. And be quite strict about it, because those are arguably the least valuable alerts. They highlight potential proactive risks, but if you miss out on more important information because you were handling those, or you were just overflowing with alerts, then they're actually hurting you. They are hurting your ability to respond to systemic problems. You might also choose to decrease some of the more proactive alerts where you know that there is a potential reliability cliff, but you still have so much that it still hurts you to respond to all of them. You are not able to. And so you climb down until you hit a happy, healthy state where you are able to manage your alert load. And the only thing you really can't reasonably compromise on is responding to when your system is actually actively broken to your users. Although even in that situation, you might be able to temporarily loosen what it means to be working to decrease the alert load. This situation can happen for a bunch of reasons. It might be that your system has systemic flaws. Maybe it has outlived the scale for which it was designed. Or it might be that the system is just fine, but the alerts have been set up in an overly sensitive way. Whatever the case may be, it is definitely a risky situation to be in. And one of the common things that you might hear is being worried about letting go alerts that might eventually show up in the retrospective, and someone will go and say in the incident retrospective, hang on a minute, we used to have an alert about this and now we don't, and now look, we have this incident. And that is absolutely a risk. However, the flip side to that is that you might have an incident where the retrospective says, yeah, we had 3 alerts about this, but we are just unable to do something about them in time, and so this incident happened. It is unfortunately a trade-off between 2 risks. The other thing this brings you is that you are able to take advantage of the time you've saved in responding to all these alerts and take a hard look at additional prioritization of reliability work or whatever work is necessary to perhaps get you out of a bad place going forward. Another anti-pattern is when you find that reactive alerts are actually not really finding the user-facing problems and outages. And this is a real problem, right? Because that means that perhaps your users called you or sent you an email, or as it is these days, escalated on Twitter, telling you, hey, your system is broken. And that is how you found out. And so the way you can tell that you're in this situation is by taking a look at your past severe incidents and seeing whether they were caused by, whether they were detected by what you would consider your reactive alerts, or whether they were detected by some other means. Now, this is quite sinister, because if you find that you do not have detection of whether users are having a bad time and go to the incident and you see, hang on a minute, 5 minutes before the user called us, there was a huge increase in CPU usage. And so you might conclude, yeah, I know what I'll do. I will add an alert on CPU usage. Now, while in isolation for that incident, that might seem like it makes sense, it is a slippery slope, because, the next incident, maybe it was because you were running out of memory slowly, you had a memory leak. And so you add an alert about that. Except the next incident is going to be about suddenly running out of file descriptors. And so now you have an alert about, is your CPU usage high? Are you slowly leaking memory? Are you running out of file descriptors? And yet you haven't really changed the key thing. You still can't tell whether users are having a good time or not. And so if you find yourself in that situation, the first thing is really to resist this urge. And it might be a very strong, very tempting urge, because nobody likes incidents. We are in the reliability business. We don't want to have these things happen to us. But odds are that by so doing, you will not actually really be improving the reliability of your system, but instead might end up with a lot of unnecessary busy work. Instead, take a step back. Look at your SLIs. Look at how you're measuring whether users are happy. It might be worth revisiting whether that measure is actually still accurate and true to the user experience itself. Another alternative is that maybe you have too sensitive a definition of what an incident is. If you have specific parts of the system which were slow for a bit and someone called you, it might be undesirable, but it might not be such a severe event to warrant potentially changing how you operate your system. All three of the anti-patterns that I've talked about here are something that I've seen and something that I've contributed to, participated in. And honestly, this is somewhat natural. At the end of the day, you want to avoid incidents, right? So how do you decide between risks on something that is very low probability but quite high impact? That is definitely a difficult problem for humans to consider. Alright, so we went through the ugly, let's go through the good. What are good patterns? What are things that might help you set up alerting for your systems over the long run and remain sustainable? So if you go with the parallel of a pyramid, then start from the base. Have a really good understanding of what matters to your users. What does it mean to be good or bad when it comes to your system? And understand that unambiguously. Now, this can be a really difficult question. And a good example is, imagine a service that serves images of cats over HTTP. This is the internet, we deal with cats. And so you send a GET request, you fetch a URL, and you get back a JPEG. So you probably expect that if it's successful, you get an HTTP 200, and that is what you would consider a good user experience. And anything else is an error. Anything else is something that you want to go and look into because you think that the user is having a bad time. Except, it's HTTP, and so HTTP 404 is a thing. Someone sometimes types the wrong URL. They get the wrong cat or they get no cat at all. Now, do you really want to go and get alerted for that? And to make this harder, sometimes people post bad links to Reddit or Slashdot or whatever the case may be. And so hundreds or thousands of people might go and click that URL and get a 404. So what you previously thought might be a bad experience might actually be a problem of the user. Now the next logical step might be, okay, I'll exclude 404 and maybe 403, so I will not care about these user problems. Except then you have few months later, you have a new release of your application, and despite your best efforts in testing and validation, there is a bug in your URL router, and you 404 every single request, and you don't know about it. So the problem here really is that you have very limited telemetry. You don't know necessarily what should have happened. You only know what HTTP return code it landed as. And now you need to make a decision. Will I page people because of it? Will I file tickets? How likely is it that this would happen? How likely it is that this would be a major incident? Now, in the case of a cat image server, the problem that I've described, a broken URL router, in practice you would probably actually catch in prior testing, and so it might not be a realistic worry. But you're also probably not running a service that serves images of cats, or at least that's not the official description. And so your actual service surface area might be much more complicated, much more nuanced, and failures like this, failures which manifest ambiguously, or rather are caused by some ambiguous circumstance, might be a lot more common. And at the end of the day, you still need to make a decision whether to alert someone on it or not. You probably guessed, this connects very strongly to the concepts of SLIs and SLOs, and so I will not belabor the point. I will mention the recently released book by Alex Hidalgo about implementing service level objectives, and I recommend checking it out if you want to read a lot more about how to reason about your SLIs and SLOs. It should be a joint decision between engineering and product management, or whoever acts in that role, because you might end up optimizing for what you can more easily measure. You might be optimizing for what leads to fewest incidents. And these can be tempting, but they can be very dangerous, especially the bias towards the most easily measurable, because a reasonable amount of prompting might actually help you find a much better metric, perhaps a better way to measure the user experience than you might initially consider. The next thing to think about is to choose your proactive alerts wisely. It's quite possible, depending on the complexity of your system, that you might have quite a wide selection of things that you could be alerting on. Running out of disk quota on your storage systems, running out of cache, decreased cache hit ratio. All of these things could potentially end up as a reliability cliff for your system. A cliff that so far everything looks good, but then your service falls down and it is hard down. And so it's really important to think about, of all that amazing wide selection of things you could be doing, how do you choose? One thing to consider is, what is the impact if the event actually happens? We've talked previously about, well, if you run out of disk space, maybe your service just no longer operates altogether. It is now effectively hard down. And so there's a bit of a step function to it. You were working just fine, and now you're completely down. In contrast, if you have perhaps a cache that helps improve the user perceived latency, if it starts getting lower cache hit ratio for whatever reason, maybe you just need more memory because your usage is just growing, while the degradation might be a lot more gradual, the user experience might be worse. In fact, it might get to an unacceptable point, but it might be slower. And so it gives you a clearer path to do something about it, and it might be also indicated in your reactive alerts. Whereas, if you run out of disk space, up until that point, if you don't have alert on it, you're just flying blind. Another aspect you might want to consider is just the probability of the event. Like, how likely is it that it will happen? And you don't have to be an expert in estimating probabilities. There are strategies to evaluate a likelihood of an event just by asking an expert. And you might be interested in the book How to Measure Anything, which talks a little bit about estimations. There's a chance that your data center will be hit by a meteorite. Will you have a proactive alert on On meteorite tracking, probably not, because the probability is so very, very tiny that you are dismissing it altogether. Now, in practice, in our distributed systems, things are not necessarily such low probability, but it is a spectrum. And so this is another dimension that you might want to use to consider and evaluate the priority of your alerts. And last, investigative alerts. How do you think about them? Well, they were in a bunch of what I was talking about. They were kind of the anti-example. Like, it is bad that you get notified about user impacting events primarily by CPU usage or whatever. But it would be wrong to walk away with the idea that they're just fundamentally flawed and useless. It's arguably unlikely that your engineers will go and look at the key metrics such as CPU or memory leaks and so on and so forth on a regular basis, especially given that 9 times out of 10 there might be nothing to see. But it doesn't mean that you need to set up these alerts and have them investigated as soon as it happens, because again, there is no timeliness inherently associated with them. What you can do is go, okay, I need some sort of notification to my engineers that something strange is going on, but it doesn't have to be handled right away. One option that might be quite successful is collect all the findings into perhaps a weekly digest. And that way you do not have to go and look at graphs and go, is something strange going on? And still you get the information more cheaply. Again, things here are a bit fuzzy. I keep using the example of CPU usage, but for some services that can be actually the key indicator of user happiness. It can be really important. And so don't over-index on that particular example. The key thing here is that for whatever the investigative element might be for you, you are able to take advantage of the fact that timeliness is not required and think really hard about what is the experience of the operator as they are receiving the notification. How can you make it as efficient as possible for them to receive the information and not be overloaded, not be overly toily like a daily graph viewing process might be. An important part of all this is, of course, that the base of the pyramid should be packed first. If you skip that, then you might land in one of the anti-patterns that we've talked about earlier. There is one specific topic that I want to look at a little bit more. Sometimes I hear, SLO alerts are the only good and right alerts, and all the other alerts are bad. Just alert on your SLOs and you're going to be fine. And this is actually demonstrably false. Service level indicators, well, they indicate the level of the service that you're providing to your users. And so as we talk, it's inherently reactive. It does not tell you what the service level will be in the future. It tells you what level of service you're providing to your users right now. This is really important information, but if you rely on it exclusively, you are hurting your ability to provide a reliable service. It means that you are robbing yourself of the opportunity of addressing problems ahead of time. And an example of this is a proactive alert I was mentioning before. You will soon run out of disk space, but right now everything is fine. If you restrict yourself to alerting on SLOs, you will not be able to respond to that event. Be data-driven. Look at your alerting over a longer period of time. Try to backtest your hypotheses for what makes a good alert or not. If you have a history of a few years of your time series, your monitoring data, then you can use that to evaluate, if only I were to alert on running out of disk space, and maybe I wrote this Prometheus expression to do so, will it alert me in time? If I decided that this is my SLI, how well would it connect to this particular incident that I've got? Similarly, use data to decide on alerting trends or to understand them. You might have heard the parable of boiling the frog, where you are increasing the heat but not noticing that something is amiss. And this can happen to our systems and services and teams as well. Every week you might have a few extra alerts than the previous one, and while no single change, no single increase is that bad, and sometimes for a while there is even a decrease, if you look at it over 6 months, 12 months, you might see a very clear trend, and maybe you might be shocked to learn that, hey, now I get twice as many alerts as I did 12 months ago. What's up with that? Similarly, beware recency bias in how you think about whether an alert is good or bad. Again, we talked about that it is kind of a subjective thing, and so if someone goes and says, yeah, that alert, I really hate it, like the last 3 times it was wrong, it alerted me and nothing was going on, it might be a cause for investigation and maybe there's a bug, but 3 data points doesn't necessarily mean that there's a trend. It's more closer to anecdote than to data. And so obviously do not dismiss it. Do not dismiss the information that you have. But the only information that you have is that last few weeks it fired 3 times and it was wrong. How about last 3 months or maybe last 3 years? Consider the alert in a broader setting. Of course, your system might evolve, your situation might evolve, your business and product portfolio might as well. And so what once was a good alert may no longer be. And so keep a critical eye in both directions. And beware simplifying sound bites like this is good or this is bad. Your actual situation is probably more nuanced than that. And so you might think of your alerting as a pyramid, as a hierarchy. You need the foundations and you can build up. And if you don't limit yourself only to reactive alerts, you might be able to improve your reliability by doing so. And stay data-driven in how you analyze the efficacy of your alerts. And lastly, the pyramid model is just that. It is just a model. And as the statistician George Box said, all models are wrong, but some models are useful. And so this model might not work for you, and that's okay. While the model might not work for you, it should open the question, well, how you're going to decide, what is the way you're going to reason about which alert is better or more important, and how do you perhaps decide that it is time to retire some alert, not because it's not giving signal, but because it is the least useful and you're in overload. That decision need doesn't really go away, even if this model doesn't work for you. Well, and that's it. Thank you very much for your time.